Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on waterflood and reservoir simulation. And in today's video, we are going to learn about how to manage a waterflood in the reservoir simulation software. And as usual, we are going to use tNavigator. We will use the sample case from tNavigator. Hopefully we can learn more about both waterflood and reservoir simulation. Okay, so this is the model. Of course, you don't see anything because I haven't checked the 3D grids. Now I check the 3D grids. This is the model, okay? And then I think better go to 3D grids like this, right click as usual and adjust size by data. And then maybe you are interested in looking at the porosity. Okay, so this is our starting model. And then, of course, when you run the simulation for waterflood, you are interested in looking at the streamline. Okay, and to do that, we go to wells and we go to strategies. We have schedule roles, development strategy. This is just a template, so you neglect them most of the time. This is our model. Okay, and you expand. We have global rules and rules in timely manner here. I want to activate the streamline, okay, since the beginning. So that's why I want to put the rule of streamlining here. So I'm going to click on add new rule at the initial, timeline. So add new rule. This is the option, the rules that we can select. Go down, go to other, and here, streamline output parameters. Click on add. Okay. So here, okay, so we have two rules. I think I better remove these rules. Okay, so I already have the rule from, from the previous, from this file that I have used previously for exercise before making this video. So I'm going to delete this. Okay, so just let's focus on this. So here, the streamline output parameters for status, we select on, phase, oil, water. Okay, but you can also check for oil, gas, oil, water, gas. Let's focus on oil, water. Source, I'm going to trace the streamline from producers, but you can also switch it to injectors. Density, it's a little bit, more challenging to explain, but if you're interested in the density, in knowing the density, I think you better go back to the tNavigator manual to understand about it. Okay, but more or less, it defines how many streamlines will be traced from one well. The number of streamlines through a phase of a block with a connection is calculated by dividing the fluid flow through the phase by the density, okay, which is here 5. Okay, so the average amount of streamlines, of a block with a connection is calculated by dividing the fluid flow through the phase by density. The average amount of streamlines can be obtained. The well rate must be divided by the density. Okay, so yeah, to understand more, you can adjust this value 5 or whatever to understand more about this. Okay, stop streamlines in blocks with low outflow. We select off. It is used to forcibly terminate the streamlines coming to the blocks where the flow is lower than signified by one streamline. Okay, usually we use off for that. Flux tolerance, sorry. So I use 10 here. Okay, so if the stream volume flowing through a phase of a block is smaller than the density to error quotient, there is no streamline running through the phase. Okay, so that's streamline or flux tolerance. Max time of flight. Okay, what is it actually? Okay, so this sets the maximum time of points movement. Max points per streamline. the maximum number of points positions recorded to create its trajectory. Max nodes per block is the maximum number of points positions within one block that are recorded to create its trajectory. And drainage table on, because later on we will review that. Okay, so now we have the streamline rules. So when you run the model, okay, you can trace the streamline. All right, but before that, of course, we need to initialize the model. Click on here for initialization, saving in progress, create new. Okay, I want to check cases here. Okay, so I don't have any result, right? It's still empty. So that's why I will create new called result1 for initialization. Okay, so now after initialization, we will have the dynamic model. Initially, we only have static model, right? And we can also go to geometry objects. This is our static model. Soon enough, we will have this, the dynamic model. Okay, and then, okay, so after this, of course, we want to run. So we are running the simulation and let's focus on the results. So this is the grids for the result. Okay, so go open the drop-down menu and here we have our streamlines.